Hi, this is Dr. Xu, teaching design of experiments for engineering research. In this video, I will teach you to make these two plots using simple R code without any programming knowledge. The R program is an open source program, and it is a powerful tool for data analysis and data visualization. Therefore, it is very popular in performing statistical analysis and the analysis of data for experiments. The dot plot and the box plot are the two commonly used plots in simple comparative experiments. The dot plot is normally used when the sample size for each variables are less than 20. In experiments for engineering research, this is the most often case as we normally try to limit the number of repeated runs below 20 to save time and cost. The dot plot plots the value for each experimental runs. And in this plot, it also shows the sample averages for the two material. In the case when you have a large sample size, a better option is to use a histogram, which is not covered in this video. On the other hand, the box plot shows the minimum value, the maximum value, the lower quantile, and the upper quantile. So the 25 percentile here and the 75 percentile here. And in the middle, the thick bar is the median value. We will use the same data for the treated material that we have been used before to show you how to make these two plots. So these are the 10 tested original material strength, and these are the 10 tested treated material strength. If you haven't installed the R program on your computer, you will need to go to this link to download the R programming and also install the Rstudio. So if we go to this link, select the red version and click install R for the first time. Click download. After finish downloading, you will need to install the program in a very similar way as what you would do to install other software. After finish installing R, now go to this Rstudio link. Click here for download. Choose the free version and download. Download the right file according to your operating system. I have Windows 10, so I click here and download, and then after finish downloading, I will install it the same way as if I install other software. After you finish these two steps, you can go to here and type in Rstudio. Here you have the Rstudio here, and click it. The Rstudio window is opened. Click File, New File, and Rscript to create a new file. You can save this to a folder where your experimental data are stored. The code we will be using in this example is shown on this slide. I have also posted it down in the video description. You can copy it and paste it to here. The pound sign here is for annotation. So anything after the pound sign, the program will not read it as command. It is only for annotation purpose, so the code is easier to understand. So anything here, after the pound sign here and here, it's not command, it's just annotation explaining what the code is doing here. Starting from line 2, I have defined a variable y1, and this sign is to pass these values to y1. And I have passed a vector. In the vector starting from C, and in the parentheses, I have the tested strength values for the original material. Similarly, I define y2 and assign a vector with the 10 treated material strength. In line 4, I have defined another variable y, and it is a data frame. In the data frame, it has the vector y1 and the vector y2. I have given the vector y1 the name of original and the vector y2 the name of treated. Line 5 it calculates the means for y, so the y1 mean and y2 mean are all calculated. In line 6, it is graphical parameters. Leave it as is for now. In line 7, I have defined the dots for one material is red and the dot for the other material is blue. And the X label is strength. 19 means the shape of the dots are solid circle. By changing this number, you can change the shape of the dots. The main label, that's the name of this plot, is the strength distribution comparison. I plot the arrows pointing to the sample average locations. Line 9 and 10, I define the text displayed next to the two arrows pointing to the average locations. And line 11, at the end of the plotting, reset the graphic settings. So later, if you have other plotting command, you can use new graphic settings. Don't need to repeat it here, so I put a pound sign here. We can also perform a t-test using this command, t.test. So the first variable is y1. So in this data frame y, the first set of values is here. And the second set of values is this. Because we can assume the population variances are equal, so we put var.equal equals to true. If the sample standard deviation differs too much and we cannot assume the population variances are equal, we need to put here false. Now select the code and hit the run button. As you can see, the name here is defined by this. These two labels are defined by here, original and treated. And the red color and blue color are defined by here, red and blue. And here is strength, it is defined by here. So this line plot the two arrows here, and these two lines define what text will be showing next to the arrows. And over here, you can see the calculated t-value, the degree of freedom, and the calculated p-value. And the test conclusion is the true difference in means is not equal to 0 because the p-value is less than 0.05. It also gives the 95% confidence interval for the difference in means. And here are the sample averages. Now you know the different components in this plot corresponding to the places in the code. It is very easy to modify this code according to your experiment and make a new plot for your experimental result. To make a box plot, we just need to comment out these couple of lines to make the dot plot and use these three lines. So I will put the pound signs in front of this. And remove these three pound signs. So here is to set the graphical parameters so the plot looks more square. And this command is to plot the data in Y as box plot. And here is to reset the graphical parameters to default. Okay, now select all this code and run. Now you have this nice looking box plot. The two labels here, original and treated, correspond to the name here, original and treated. The Y label strength here is here, strength. And there is no other parameters in this plot. So now you have learned to use less than 10 lines of R code to make this dot plot and box plot. Will it be exciting that next time when you have experimental data, you can make these two plots and include them in your presentation to surprise your advisor? You can also include such plots in the next paper you are preparing to submit to a journal and improve the paper's graphical appearance. So make sure to try it out using your own experimental data. If you have other ideas of making such plots, please leave a comment and I'd love to learn from you as well. This is Dr. Xu. Thank you very much for watching. I will see you in the next video.